Coming to our next topic, it is methods of finding the volume of an irregular object. So there are two ways to find the volume of an irregular object. One of them includes the difference in volume method, and the other one is Eureka can or displacement can method. Now first, coming to difference in volume method, where there is a question we get in our exams which states that describe an experiment to find the volume of the stone as accurately as possible. Always remember that according to marking scheme, whenever the question says to describe an experiment as accurately as possible, then we must give the steps and procedures along with clear precautions to make the results accurate. Means that whenever the question includes that as accurately as possible, it also means to write down the points which are used to write down the points which are used to make the experiment more accurate, more reliable. So if the question was only describe an experiment to find the volume of the stone, then we will only write the steps and the procedures to carry out the experiment. But whenever it says as accurately as possible, then we must also include those points which make the experiment more accurate or the results more reliable. So coming to its answer, describe an experiment to find the volume of the stone as accurately as possible. How to find the volume of a stone which is an irregular object. Remember that stone is an irregular object. So how to find the volume of an irregular object or of stone as accurately as possible? So your answer should be: add a known volume of water into the measuring cylinder and note down its reading as V1. First, we will take a beaker, you can suppose, and we'll take a known volume of water, like you can say 30 centimeter cube of water in the beaker, and you will measure the volume of the water that we have supposed it here to be 30 centimeter cube. Then next what you have to do, you have to gently immerse the stone into the water in the cylinder or beaker. It's the same thing, you can even take a beaker. So we remember that we have to gently immerse the stone into the water in the cylinder. We will not throw it. I will tell you ahead why we will not throw it, why we will have to gently immerse it. So remember to gently immerse the stone into the water in the cylinder. Gently immerse the stone into the water in the cylinder. Then what next you have to do, you have to gently tap the cylinder a few times and note down the final reading as V2. I will also tell you why we have to tap the cylinder gently a few times, but right now you must only write it that gently tap the cylinder a few times and note down the final reading as V2. Means that before noting down the final volume after the water has gained some height, after the stone has added, before that you have to gently tap the cylinder a few times. I will tell you ahead why we have to tap the cylinder a few times. So after we have noted down the value V2 of the water, final volume of the water V2, then we have to subtract V1, the first volume we noted, and the known volume we noted, and then subtract V1 from V2 to get the volume of the stone. Now what does this sentence mean here? Subtract V1 from V2. It means that whenever it comes from, remember that whenever it comes, subtract from. So we swap their places. V2 will get on the V2 will exchange place. V2 and V1 will exchange their places with each other. Means that it would become V2 minus V1. So actually this sentence means that subtract V1 from V2 to get the volume of the stone. So as you know that V2 will be greater, V1 will be lesser in volume. uh, because V2 is the final reading after immersing the stone into the into the water in the cylinder, and after which the water has gained some height, so V2 will be larger, will be greater, and V1 will be lesser. So that is why we will subtract V2 from V1, not V1 from V2. So the here this from actually exchanges their replace them with each other. So subtract V1 from V2 to get the volume of the stone. Then ahead, now as we read that the question was describe an experiment, and then as accurately as possible it was written in the end. Now we have come to those points, points which are related to accuracy of the experiment, how to make it more accurate and how to make the results more reliable. So here are the points. Avoid parallax error while noting down the reading of V1 and V2 by placing the line of sight exactly perpendicular to scale. I will tell you ahead in further. I will tell you in upcoming videos that what is parallax error. Right now, you can just note it down, and you can also see by yourself that it is the point related to accuracy and reliability of the results of the experiment. So this is the first point, that avoid parallax error while noting down the reading of V1 and V2 by placing the line of sight exactly perpendicular to scale. I can give you just rough idea of this type of parallax of this type of error. Like if this is your eye, uh, this is your eye, and here is your scale, and if you and here is the mark you want to which we want to measure. So you will look straight perpendicular from this is the line of sight, and you have to place your eye in such a position that it is perpendicular to the reading. If you place it over here, your eye, then you will get reading somewhere over here, and if you place it somewhere up ahead, then you will get reading from here, over here somewhere. Like if you need to look at a time, I can give you a daily life example. If you want to look if you want to know that what's the time right now, and you look at your wall clock, you look at such a distance that you know that your line of sight is perpendicular to the needles of the clock, and you know the exact time, the accurate time. If you look it from downwards, you can't actually clearly see or know what's the time. Or if you even look it from upwards, from elevation, you even then you don't get the accurate time. So this is one example, but I will explain you it in upcoming videos in detail, that what is parallax error. Right now you can write down this point, avoid parallax error while noting down the reading of V1 and V2 by placing the line of sight exactly perpendicular to scale. Now coming to the next point, it says place the measuring cylinder on a flat horizontal surface, read the correct meniscus level. And this we have to you must have read in your junior classes that there is a meniscus level. Like if this is a beaker, and there's a water like this, and there is another beaker, water in it, water is like this. In order to the water gets this downward curve or upward curve light shape when it is placed on a flat horizontal surface. So in order to get the you in this experiment, the first point the second point is the second point of accuracy is that place the measuring cylinder on a flat horizontal surface. You always have to place the measuring cylinder on a flat horizontal surface. If you don't do that, like if you place the measuring cylinder on a slopy area, like then it would be somewhat like somewhat like the water would be like this, and you can't measure the accurate and you will not get the accurate results. So you have to place the measuring cylinder on a flat horizontal surface, and when you place the measuring cylinder on a flat horizontal surface, the water adapts to shape like this, which this or this. This is the downward curve and this is the upward curve. And then we have to what do we have to do in in this type of situation? We have to read the correct meniscus level. We call it this downward curve and upward curve, we call it meniscus. And we always have to, like, let me draw over here. If we draw it like this, and this is the downward this is the downward curve and this is the upward curve, and this is the meniscus. And now you would be thinking that would we read it from here, or would we read it from here or here or here? You just have to note that where is the top edge, or where is the where is the lowest point in the downward curve of the meniscus level, which is this, and where is the highest point of the upward curve, upward meniscus in this case, which is this. So you always whenever the curve is downwards, you have to take its lowest point, which would be this, and whenever the meniscus is upwards, you have to take its highest point, which is this. So these are the correct meniscus levels, which will give you accurate and reliable results. So this was the answer of the question, and these last 3 points were the accuracy points. How to make your answer accurate. So coming to the next question, these are the short questions which I told you in the answer, that I will tell you why is this and why is that. And one of them is, explain why the stone is gently immersed into the cylinder. Here I told you that gently immerse the stone into the water in the cylinder after adding a known volume of water into the measuring cylinder and noting down its reading as V1. After means that it was the starting of the experiment when we have added a certain volume of water into the cylinder and noted down its reading as V1. Then we immerse the stone into the water like this. We immerse the stone into the water. Why we have to gently immerse the stone? You will get its answer in this question, which is, explain why the stone is gently immersed into the cylinder. It is immersed to prevent the splashes of water from going out of the cylinder and giving us inaccurate volume of water. Like if you literally throw the stone into the water, the splashes of water will come out, and the volume, the V1 volume which you noted in your experiment earlier will decrease and will not be the same as V1. So when you will subtract V1 from V2, you will not get the accurate or the reliable result, because some of the water already splashed out from the beaker in the beginning, and your result will not be accurate. So in order to prevent this unreliable result, you have to gently immerse the stone into the water in the cylinder in order to prevent the splashes of water from going out of the cylinder and giving us inaccurate volume of water in the end. Next question, explain why the cylinder is tapped a few times before noting down the final volume of water. Okay, now I told you that when you have added the stone into the cylinder, gently immerse the stone into the water in the cylinder. Then you have to gently tap the cylinder a few times before noting down its final reading as V2. Why we have to do that? Because because you know that if we initially take a water in a beaker, there are some bubbles in the water, small air bubbles in the water. So in order to evacuate these dissolved air bubbles from the water in the cylinder, we have to gently tap the cylinder a few times. So these were the answers for the queries which we faced in the answer of this question. So these are also clear. So better luck. Now your this question is complete, fully complete. Now, in order to make you guys more clear, I have listed down the question that list the precautions that must be taken to find the volume of water in the cylinder. That it is the part of the previous question, which was describe an experiment to find the volume of the stone as accurately as possible. But here it only says list the precautions, so we only have to list those last 3 points, which were on accuracy and getting reliable results, which were these: avoid parallax error, place the measuring cylinder on a flat horizontal surface, and correct meniscus level. So here it only asks us for the precautions that we need to take to measure the volume of the water in the cylinder. So in order to in order to list down only the precautions, we will just copy these we will just copy paste these last 3 points and write them as the answer to this question. As you can also see, we can read this: place the cylinder on a flat horizontal surface, avoid parallax error by placing the line of sight exactly perpendicular to the scale, and read the correct meniscus level. These were the last 3 points to that question too. So which we will write in here in this question, which demands us for the precautions. So coming to next question, explain the significance. This is a new question, also related to that previous question, which asks us which states that explain the significance of 25 degrees Celsius mentioned in the cylinder. That here it says that why it is important to place the cylinder at 25 degrees Celsius when doing all that experiment of measuring the volume of the stone as accurately as possible. Why we need to place the cylinder at 25 degrees Celsius? What is the significance of placing the cylinder uh, which contains the stone in 25 degrees Celsius? So the answer to this question includes that this temperature value means that the cylinder will give us the accurate readings of the volume of the liquid if kept in a temperature of 25 degrees Celsius, which is a room temperature. And why do we have to place it in a temperature of 25 degrees Celsius, which is the room temperature? Because if we place the cylinder with the water and the stone in a colder or warmer conditions, the cylinder will give us greater or lesser readings, so that will be inaccurate. And for the volume of the liquid, giving us ignore the noise, giving us inaccurate results for the experiment. So that marks the completion of your this topic, not the chapter. So this is the complete answer to this question.